Many textbooks define random sampling as a process in which every member of a population has an equal probability of being selected. While this is true in an ideal world or a closed system, does it hold in the empirical world? In reality, phenomena may appear to follow equal chances, but hidden biases often influence outcomes, leading observers to mistakenly assume that chance alone governs the process. A more practical way to conceptualize random sampling is as a process where each member of the population has an independent chance of being selected. In other words, the probability of one individual being chosen is not affected by the selection of others. Let's consider some real-world examples to illustrate this point. 1. Promotional event example. Long time ago, I participated in a Sony camera promotional event where the host randomly threw out free gifts like caps and t-shirts. Did everyone in the room have an equal chance of catching a gift? Not really. Those seated far away were less likely to get one. Surprisingly, those seated too close to the host also had a lower chance because it's more natural for someone to throw gifts farther out rather than simply hand them to the nearest row. Additionally, taller individuals with a long arm had an advantage. They could intercept gifts flying through the air. 2. Raffle example. When a host draws tickets for a raffle, they often reach deep into the box to pull a ticket, avoiding those on the top. Why? Likely, to avoid accusations of favoritism. As a result, tickets on the top have a lower chance of being drawn. 3. Dot placement example. When asking someone to randomly place dots on a blank piece of paper, they rarely position dots near the edges. Most people naturally gravitate toward the center. Thus, not all parts of the paper have an equal chance of receiving a dot. These examples highlight how real-world processes often deviate from the theoretical notion of equal chances. In practice, the line between random sampling and convenience sampling often blurs. For instance, suppose I select a random sample of students from a list and send them email invitations to participate in a study. Some will agree to join, and others will decline. But this yes, no response is not random in the equal chance sense. If I offer incentives, like extra credit or a $10 gift card, students who value those rewards more, needing extra credit or money, are more likely to participate. Thus, not all students have equal chances to participate. Now consider a hypothetical population of 1,000 people in a country called USX. If I want to select 2 participants, the theoretical probability of selection for each individual is 2 out of 1,000. But populations are dynamic, not static. The population size keeps changing due to births, deaths, immigration, and emigration. As a result, the probabilities constantly shift: 2 over 1011, 2 over 999, 2 over 1003, and so on. Another scenario involves giving away 3 gift cards to students using sampling without replacement. If there are 20 tickets in a bag, the chance of being selected changes with each draw. For the first draw, the probability is 1 over 20, for the second, it's 1 over 19, and for the third, 1 over 18. Statistical inferences based on random sampling often assume that every member of the population has an equal chance of being selected. However, one cannot sample from future members of the population. Individuals not yet born or who enter the population after the sampling event have a 0 chance of being included. This makes a truly random sample impossible in a dynamic, real-world population. This issue can be addressed by associating random sampling with independent chances rather than insisting on equal chances. While the concept of equal chances is a useful mathematical ideal, it applies only in closed systems. Perfect equality rarely occurs in the real world. Ultimately, I'm not suggesting we abandon the idea of equal chances altogether. But it's crucial to recognize it as an idealized construct, not an empirical reality. I hope this discussion encourages you to think critically when engaging with textbook definitions. Mahalo.